a celestial wanderer. Introducing Asteroid Apus. Asteroid Apus is a near-Earth object that has captured the attention of astronomers and space enthusiasts alike. Discovered in 1989, Apus is a sizable celestial body, measuring approximately 1.3 kilometers in diameter. This makes it larger than 90% of known asteroids. Based on its size and composition, scientists estimate its weight to be billions of tons. Apus is classified as an Apollo asteroid, meaning its orbit crosses Earth's path around the Sun. While this might sound alarming, it's important to remember that space is vast and collisions are relatively rare. Nonetheless, Apus's size and trajectory warrant careful observation and study. Understanding its composition, trajectory, and potential for future close approaches is crucial for assessing any potential risks it might pose to our planet. The ominous name, Apus's trajectory, and close approaches. The asteroid's name, Apus, is derived from Greek mythology, specifically the story of Arcus. In these ancient tales, names often carry significant meanings and stories. Arcus's mother was transformed into a bear, and Arcus, not recognizing her, nearly killed her in a hunt. This mythological story is a poignant reminder of the complexities and tragedies in ancient lore. To prevent this tragedy, Zeus intervened and placed both mother and son in the sky as constellations. These constellations are still visible today, telling their story across the night sky. However, the story of Apus is not as heartwarming. It carries a sense of foreboding and mystery. It takes its name from the bird of paradise constellation Apus, which is Latin for no feet. This name hints at the asteroid's unpredictable nature. This name foreshadows the asteroid's potential for chaos, as it suggests a celestial body tumbling uncontrollably through space. The imagery of a footless bird adds to the sense of instability. Adding to its ominous nature, Apus is set to make a close approach to Earth on Friday, April 13, 2029. This date, often associated with bad luck, adds to the tension. On this day, Apus will come within approximately 30,000 kilometers of our planet. This is an incredibly close distance in astronomical terms. This is closer than some satellites orbiting Earth. The proximity of Apus will be a significant event for astronomers and space enthusiasts alike. However, scientists have carefully charted Apus's trajectory and have determined that there is no risk of impact in 2029. Their calculations provide reassurance amidst the excitement. While this close encounter provides a unique opportunity for observation, it also serves as a stark reminder of the potential threats that exist in the cosmos. The universe is full of wonders and dangers, and Apus is a testament to that duality. Echoes of the past. The 2013 Chelyabinsk meteor and the Tunguska event, two of the most significant cosmic events in recent history. While the prospect of a large asteroid impact might seem like the stuff of science fiction, recent events remind us that such threats are a real possibility. These celestial objects, traveling at incredible speeds, can cause unimaginable destruction if they collide with Earth. In 2013, the Chelyabinsk meteor, an asteroid approximately 20 meters in diameter, entered Earth's atmosphere over Russia. It was a bright morning when the sky lit up with a blinding flash, followed by a deafening explosion. The meteor exploded in the air, releasing energy equivalent to roughly 30 Hiroshima atomic bombs. The explosion created a massive fireball and a powerful shockwave that traveled for miles. The resulting shockwave caused widespread damage, injuring over 1,500 people and damaging thousands of buildings. Windows shattered, walls cracked, and the ground shook violently, leaving the city in chaos. Even more dramatic was the Tunguska event of 1908. An event that still baffles scientists to this day. A massive explosion, attributed to an asteroid or comet, occurred near the Tunguska River in Siberia. The explosion was so powerful that it was heard hundreds of miles away. The blast flattened trees over an area of 2,150 square kilometers, with an estimated energy release 1,000 times greater than the atomic bomb dropped on Hiroshima. The sheer force of the explosion left a lasting mark on the landscape. Thankfully, the remote location of the impact minimized casualties, but the event serves as a chilling reminder of the destructive power of even relatively small celestial objects. These events underscore the importance of monitoring the skies for potential threats. The challenge of detection. Finding asteroids in the cosmic haystack. The Chelyabinsk and Tunguska events highlight the importance of early asteroid detection. However, finding these celestial wanderers is no easy task. Asteroids are often dark and difficult to spot against the blackness of space. They can also be incredibly small, making them even harder to detect until they are relatively close to Earth. Adding to the challenge, some asteroids, like the one that caused the Chelyabinsk event, approach Earth from the direction of the Sun. The Sun's glare makes it nearly impossible to detect these objects using traditional telescopes. This blind spot in our detection capabilities underscores the need for advanced observation techniques and continuous monitoring of the skies. A planetary defense, the DART mission and its impact. Recognizing the threat posed by near-Earth objects, space agencies worldwide are actively developing planetary defense strategies. One such effort is NASA's Double Asteroid Redirection Test, or DART mission. Launched in 2021, the DART spacecraft successfully impacted the small asteroid moonlet Dimorphos in 2022. The goal of the DART mission was to test the feasibility of deflecting an asteroid's trajectory. By crashing a spacecraft into Dimorphos, scientists aim to slightly alter its orbit around the larger asteroid Didymos. This groundbreaking experiment demonstrated that humans have the capability to alter the course of celestial bodies, potentially averting a catastrophic impact in the future. The importance of vigilance, early detection and tracking of near-Earth objects. The DART mission marked a significant step forward in planetary defense, but our work is far from over. Early detection and continuous tracking of near-Earth objects are paramount to ensuring our planet's safety. Astronomers are constantly scanning the skies, using increasingly sophisticated telescopes and data analysis techniques to identify and monitor potential threats. International collaboration is also crucial. By sharing data and resources, we can improve our collective ability to detect and track asteroids, as well as develop coordinated response plans should the need arise. Public awareness and education are also vital. By understanding the risks posed by asteroids and supporting space exploration efforts, we can all play a role in safeguarding our planet's future. The future of planetary defense, international collaboration, and technological advancements. Looking ahead, the field of planetary defense is poised for continued growth and innovation, driven by the relentless pursuit of knowledge and the need to protect our planet. Researchers are exploring a range of deflection techniques, including gravity tractors, laser ablation, and other cutting-edge methods that could one day save Earth from a catastrophic impact. And kinetic impactors like DART, which demonstrate the potential of direct intervention in altering an asteroid's trajectory. These technologies, combined with advancements in asteroid detection and tracking, offer hope for a future where we can effectively mitigate the threat posed by near-Earth objects, ensuring the safety of our planet. However, technological advancements alone are not enough. The complexity of planetary defense requires a multifaceted approach. International cooperation and collaboration are essential for a robust planetary defense system. No single nation can tackle this challenge alone. By working together, sharing knowledge and pooling resources, we can ensure the long-term safety of our planet and its inhabitants, fostering a spirit of unity and shared responsibility. The future of humanity may very well depend on our ability to protect ourselves from these celestial wanderers. Our collective efforts today will shape the destiny of future generations. By investing in scientific research, technological development, and international partnerships, we can face the challenges of asteroid threats head-on and ensure a safer future for generations to come, securing the legacy of our civilization.